All positive displacement compressors generate pressure by drawing vapor into a compression chamber, sealing the chamber, and then shrinking the volume of the chamber. There are 4 common types of positive displacement compressors: screw compressors, reciprocating or piston compressors, rotary vane compressors, and scroll compressors.
So one way to think about a positive displacement compressor to help you understand how it works is to think through what happens in your own lungs when you blow up a balloon. Everyone's familiar with that feeling of blowing up a balloon. First, you take a deep breath in. In doing that, you feel your lungs expand. That's because you increase the volume of the lung as you drew vapor or air into your lungs. Then you want to push that air out, so you contract your lungs, which reduces the volume of the lung and increases its pressure, which pushes the air out and into the balloon. That's helpful to understand how a positive displacement compressor works.
Screw compressors utilize meshing rotors to force the gas into smaller volumes, which increase the pressure as the gas passes through the screw compressor. A reciprocating compressor uses pistons moving back and forth to reduce the volume in a cylinder, which increases the pressure of the vapor inside the cylinder. A rotary vane compressor employs centrifugal force to move vanes inside a rotor that rotates off-center with the cylinder. Vapor is trapped between the vane, rotor, and cylinder. As the rotor spins, the volume shrinks because the rotor is offset from the vane. A scroll compressor has one fixed scroll and a second rotating scroll. As the rotating scroll moves, the refrigerant vapor is pushed to the center of the 2 scrolls, causing a reduction in gas volume. Scroll compressors are not used in industrial refrigeration applications.
So it's kind of easy to understand in general how a positive displacement compressor works. It takes a volume, traps it, and squeezes it. But understanding the differences between the 3 categories can be a bit challenging. So here's my attempt to help explain that. Let's start with reciprocating. We've probably all worked with a bike pump before. Here's just like a simple bicycle pump that you use to fill up air on a bike tire. And this really is very similar to a reciprocating compressor or a cylinder in a reciprocating compressor. As I pull this handle out, I'm increasing the volume in my cylinder, drawing air into the cylinder. Then as I squeeze this down, I push air out. Now right now, because nothing's connected, there's no resistance to this as I push it. So it's really not compressing anything because I can just move this freely. However, even just by putting my finger over this, I can feel now pressure against this because that air is trapped in there and I'm not letting it go. So that's positive displacement category 1, reciprocating compressors. Now we move on to the screw compressor. That's a bit more challenging to visualize. I have this pretty cool model though that helps. Just a plastic model, but it shows the two rotating screws that are meshed together, the male and the female rotor, suction coming in through here and then exiting at a lower velocity down here. Now, even with the naked eye, you can't see how this is machined to trap the volume and reduce it, but it does show you how the screws mesh together. And with a little bit of imagination, I think you can understand that in the machining process, by narrowing the channels, the vapor gets squeezed and squeezed and squeezed until when it leaves, it's at a higher pressure. So category number 2, screw compressors. The third category of positive displacement compressors is the rotary vane compressor. And unfortunately, I don't have a cool model on that one, but I did print this off the internet, which gives a basic cutaway of a rotary vane compressor and how it works. So first, just notice the suction port, which is here at the top, that's where vapor would enter, is much larger than the discharge port. So that's true with all compressors. You're gonna have a larger suction than discharge because in the compression process, the vapor is gonna occupy less volume. It enters into this small compression pocket. And now notice this circle here, which is the rotor, is offset from the larger casing. And that's very, very important. These blades that we see here are able to slide in and out of that rotor. They're cut into the rotor and they can slide freely. So as the rotor is spinning, these blades by centrifugal force want to move outward. They're prevented to by the casing itself, but as this spins, And because this is offset, the volume occupied by each one of these small compression chambers, which is showing just a different spot in the rotation, is getting, see, that's probably the biggest one. It's getting smaller, smaller, and very small until it exits the compressor at its very lowest volume. So hopefully that's helpful to understand that third category, rotary vane compressors.